Hi, and welcome back to the Anatomy of Synergy. The purpose of this series is to demonstrate how to create and assemble the building blocks that comprise a Synergy application. In the last video, we discussed the implied decimal data type. In this video, we'll cover the integer type. Let's get started. Like the decimal data type we examined in a previous video, the integer data type stores whole numbers. The difference is in how the numbers are stored. Decimal data stores numbers as ASCII characters, with each digit represented by a character. Integer data, in contrast, stores the binary representation of a number. Because integer fields don't require an entire byte for each digit, they can store data more efficiently than decimal fields. But the trade-off is that the integer data is harder for humans to read. Let's look at how to define an integer field. Not surprisingly, integer fields are defined with the letter I. As with other data types we've discussed, the number after the letter determines how many bytes the field takes up in memory. But unlike previous data types, an integer doesn't use 1 byte for each digit, and therefore the size of an integer field doesn't equal the maximum number of characters in the field. Also, the size of an integer field is limited to one of 4 options. It can be an I1, I2, I4, or I8. If you specify any other size, you'll get a build error. Alternatively, you can define an integer as an I star and provide an initial value. The compiler will create a field with enough bytes to hold that value. In traditional Synergy, you can also define an integer using a keyword. Byte or sbyte, short, int, or long, which maps to I1, I2, I4, and I8 respectively. Although the keywords refer to something different in Synergy.net, and therefore you can't use them interchangeably. You can use the Synergy integer types I1, I2, I4, and I8 in both traditional Synergy and Synergy.net. An I1, which is a single byte, has 256 possible values, from -128 to +127. The other sizes have corresponding minimums and maximums for 2, 4, and 8-byte binary values. You'll notice that all of these integer types are signed. They can contain both positive and negative values. Now let's compare the largest integer value with the largest decimal value. The maximum value of an integer is huge, nearly 10 to the 19th power. The maximum value of a decimal is much larger than that, but it also takes up a lot more space. While an I8 only uses 8 bytes to store its maximum value, a decimal field needs at least 19 bytes to store the same value. One last thing to mention is the HatVal return type. In the first video in this series, we saw that HatVal is the default return type for functions created with the function code snippet. The HatVal type is also an integer type, but it's only used as the return type for routines, not as the defined type for a field in a record. A HatVal value is a native integer, which means that its size is determined by the configuration used to build it. For example, if a function is compiled for 32-bit Synergy, a HatVal will be 32 bits long, or an I4. If a function is compiled for 64-bit Synergy, a HatVal will be 64 bits long, or an I8. If we have an integer value in a function, we can return it to the calling routine with freturn. We can also return a smaller-sized integer. A function that wants to return an integer doesn't need to use the HatVal type. For example, we could explicitly define the return type as an I8. Synergy treats HatVal functions a bit differently than other functions, but for now, simply remember that a routine with a HatVal return type can return integer values. This concludes our introduction to integer data. We've learned how to define integer fields and what sizes are supported. We've seen that a HatVal function returns integer values. In our next video, we'll introduce strings in Synergy. Thanks for watching!